class. So this is part 2 of our t-test lecture, and so it's important that you watch part 1, and I would ask you just to take a quick moment to do a quick brain dump. Remember those key things. What are the 3 types of t-tests? What are the designs that go with each? Can you think of examples of each? And then what is going on in the t-test formula for independent t-test, which is the first t-test that we've covered. So we're moving on with this, and part 2 connects to your Facebook homework. And so we're just going to go over some more with calculating that independent t. Facebook uses a lot of data for us, and actually there's a lot of data that's taken from us everywhere in this world of big data. If you're interested in exploring some of those things that it does, you can click on those links in my PowerPoint. So all of these PowerPoints are up. Even if my video cuts off some of the PowerPoint, you've got the PowerPoints in the Canvas modules. And so one thing you can look at is website user experience. And so some people would see a website that looks like one way, some people would look at a website that looks another way. And so my example, the websites are the same. The only difference there is you've got a green button and a blue button, and you're seeing more people will click if it's a green button than it's a blue button. So again, a lot of user interface, usability experience can be done using t-tests and looking at this data. So I was thinking about this, and I decided to explore some of my own Facebook data. And so I wanted to look at, do I have more mutual friends with family members, or do I have more mutual friends with friends? And so this is a case where I'm going through and I'm looking at number of friends, mutual friends. And so number of mutual friends is my dependent variable. And I'm interested in seeing if there's differences between these 2 groups of people in my life, my family and my friends. And so I went through and did a quick sample. I do have more friends than 30 on Facebook, but I went ahead and looked at 30 individuals. And you can see some more information of this data as part of your Facebook homework. But it was a sample of 30 individuals. This is what it would look like if I was imputing the data. And so I have subject number, that's just a basic ID number. I don't do anything with the calculations for that. I have my outcome variable, which is number of mutual friends. And then my family category, a 1 if that person is a family member, 2 if a person is a friend. And so you can kind of see when you go on Facebook, if you are on Facebook, you can see your friends, and then you can see, it tells you who are the mutual friends you have with those people. So again, kind of simple, silly example here. And so then I went through and I created data for this. So I used my actual data, and then I made up and fudged some data. And part of the reason I fudged some data is because if you look at your Facebook t-test handout, you will see I have a large standard deviation in both my family number of mutual friends and my friends' mutual friends. So the fortunate thing with this is I did meet the quality of variance for both data sets, but data set 1 is the original data set. But it's really large. It's like 18 or 19. That's really big. That means I have a wide variation in mutual friends for friends and for family. So then I did run the independent t-test, and I saw my t was very low. It was 1.09. If you look at that output, again, I encourage you to be pulling up that Facebook handout sheet to look at it, but I've got a little picture of this. You can see that the value is 1.09. You can see my p is 0.283. It also shows you a Cohen's d, and my Cohen's d is actually 0.4, which I'm going to have you about that, because Cohen's d of 0.4, if you remember from our lecture with effect sizes, I kind of briefly showed you that. But a 0.4 is a small effect, and typically you wouldn't see a small effect if you had non-significant results. So a t of 1 with a p of 0.2 is not significant. So I want you to think about what error that might be, and you can message me. I'll give you a point extra credit for thinking about that. So I've got a difference there, and look at those review slides. They tell you some more about those differences. So again, that output also shows my general means between the two groups. So then I was like, okay, I have a lot of variance going on there, a lot of larger standard deviations. I'm going to make up some data that's a little bit smaller. So I fudged my data, and that's actually the data set 1. Data set 2 in these slides is my original one. And now my standard deviations, again, if you look at this, it's the second part of your handout, is smaller. They're around 7 people, again, for both groups. So again, I met the assumptions for equality of variance, and so for this, that's this test right here. You want a p that's greater than 0.05, and mine was definitely greater than 0.05. You can look at the handout and see that. For this one, you can see the t is significant here. And so your t is 2 point something, 7 something. Look at those handouts, and the p-value is small enough, and a Cohen's d is 0.59. And so again, I'm going to have you kind of think about this data a little bit more, look at this data. You're going to be going through and making those calculations. So again, when you calculate t, you have your standard deviation right here. Right? There is standard error in this, but it's standard error. It's not the pooled standard error. So you're going to be using these standard deviations. Again, you're going to be making those standard deviations into variance, and then you're going to be using that variance as well as your degrees of freedom to be making these calculations. So you're going to be using this formula right here. Your degrees of df1 and df2, I'm going to go back to our data. Your degrees of freedom 1 and degrees of freedom 2 is your number. So in group 1 I had 13. 13 minus 1 is 12. So that's my degrees of freedom group 1. Degrees of freedom group 2 is 17 minus 1 is 16. Over df total. df total is going to be that 30 minus 2, which is 28, which is also 12 plus 16. So that's going to be your homework for your for our t-test this week, as well as a Mythbusters homework that I hope it's kind of fun for you guys to do. So I wanted to kind of wrap up thinking about now what you know about t. T is mean differences over estimated standard error, and again, estimated standard error, and that's going to be the case for all t's. And estimated standard error is going to be connected to sample size as well as variance. So I want you to kind of think about this learning check. So if I wanted to make a significant t, which means I want my t to be big, right? I want it in that critical value region. What would I want, right? So you have those 4 different options there. Option A, a small mean difference, that's going to be a small number at top. A small sample variance, that's going to go into that formula for the bottom. A large mean difference and a large sample variance, or a small mean difference and a large sample variance, or a large mean difference and small sample variances. So I'm going to give you a minute to think about that. And at the end of this clip, I'll tell you the answer. So let's review these key points. So again, key points, independent t-test. Why do we run that? We have 2 different samples. We have a normal distribution. We have an outcome variable that's data. When we're doing hypothesis testing, again, we want t to be much greater than 0, but 0 is that middle point. If it gets past that critical value, then we have a p of less than 0.05, assuming we set our alpha 0.05, and that's pretty typical. Then if I've got it on the outside, and it's a large t, then it's likely that I'm at a p less than 0.05. If I have a p less than 0.05, then I reject the null, which means I have significant differences. If I have a t that's smaller, kind of that closer to that 0, that's in the fail to reject the null region. And that means I'm not going to have a significant t. Regardless if my t is significant or not, I do want to do effect size, and so the one we're going to focus on the most is Cohen's d. I'm not having you calculate that, but if you're given Cohen's d, I'd want you to make sense of that, which you will be doing in your homework, and again, you have that extra credit option to message me. And then I gave you some, and again, equality of variance, super important. That was part of that output I had showed you. We talked a little bit about that in part 1 of the video. And then I gave you how is this typically reported. So I gave you that as well. So this is the wrap up of part 2 for our t-test lecture. Part 3 is going to handle Chapter 7, connected to paired, dependent, or related t-tests. Again, all of those are the same thing, where I get 2 cups of tea or you get 2 cups of tea.